Hi and welcome back. We have just finished our introduction to graphing in the family of functions unit. We looked at the different shapes of the graphs for the individual families, their parent functions, and how transformations play a part in moving them about the coordinate plane and what that does to the equation. Now we're going to take a look at domain and range. What are our input values and our output values? If we remember, the domain of a function is a set of values for the independent variable or the x values that we're going to put into the function. Um, and these can be just about anything we want. We just pick them. They don't rely on anything. There are a couple situations, though, where we will get undefined answers. And there are two that we're going to look at here that are undefined. And you'll hear me in class say that's illegal, meaning you can't do it. There's not a mathematical way of doing it. The first one we're going to look at is the square root of a negative number. And the second one is division by zero. So first, we're going to look at, the square root of a negative number. And since it can't successfully act, the square root can't, on a negative number, we need to define that range. And let me give you a couple real number examples. So if I have the square root of 25, I need to find a number multiplied by itself that will give me positive 25. Well, that's going to be positive 5 times positive 5, or negative 5 times negative 5. Both of those situations will give me the positive 25. If, however, we need to find the square root of negative 25, do I have a number multiplied by itself that will give me negative 25? Well, I know 5 times 5 will give me a product of negative 25. But if I need to have a negative 5 times a positive 5, and so I really can't use the square root on a negative number. It is undefined or illegal. So since it can't successfully act on that negative number, the domain has to be all real numbers such that x is greater than or equal to 0. In set notation, we'd write this, and we did this a little bit earlier on, x such that x is greater than or equal to 0, when we simply have the for f of x equals the square root of x. And we'll look at different situations a little bit further on where we have more than the variable underneath the square root sign. Next, I've told you that division by zero is undefined. What do I mean by that? Every division problem, if you recall, has a related multiplication problem. So if I have 6 divided by 3, that will produce 2. The related multiplication problem is 3 times 2 will give me a product of 6. Let's look at an example where we're dividing by 0. 6 divided by 0 is what? Well, let's look at that related multiplication problem. What times 0 will give me a product of 6? And the answer to that is nothing. That's why division by 0 is undefined. We cannot find a number when multiplied by 0 that will give us any other number but 0. So division by 0 is undefined. And we worked with this a little bit earlier in our function family of functions unit, we need to find the excluded values. So what you do here is you take the denominator, which is what we're dividing by, and we say that x plus 2 cannot equal 0. Then we go ahead and solve for x. Just get x isolated on one side. I'm going to subtract 2. X cannot equal -2. And it's that simple. So writing this in set notation, I'm going to have my sets x, all of x, such that x does not equal -2. That's going to give me an undefined answer, and I can't do that. So what do we do in determining the domain when we have more than just the simple variable under the square root sign? First off, what are my restrictions here? Whatever is underneath that square root sign can't be negative. In other words, it has to be positive. So the expression underneath the square root sign has to be greater than or equal to 0. So I am going to set my expression underneath the square root sign. In this case, it is x plus 7, and say whatever that is has to be larger than 0. Solve for x. X has to be greater than or equal to -7. And then my last step is to write that into set notation. Once again, well, that's a funky looking set, but we'll go with it. X has to be all of x such that x has to be greater than or equal to -7. What do we need to take special consideration of when we're dealing with solving inequalities? We did this back in our algebra review unit. If we divide or multiply by a negative, we need to flip that inequality sign around. Don't forget that. If you happen to have a coefficient on your variable that's negative, and you're going to divide or multiply by a negative to get rid of it. Sometimes when we're looking at a function and trying to determine the domain, we have a more complex denominator. So if you happen to have a polynomial in your denominator, sometimes you may have to factor that denominator if you can and if necessary. Next, we're going to set each binomial equal, not equal, to 0 and solve and see what values we want to avoid. Then we're going to write it in set notation. So here I have a denominator of x squared plus 7x plus 10. So my first step says to factor that if I can and if possible. And necessary, well, it's definitely necessary. Let's see if it's possible. Factoring steps. First, let's review those. Do I have a greatest common factor between those three terms? Got 1, 7, and 10 as my digits. Nothing common there besides 1. And I don't have a variable on that third term, 10, so nope, I don't have a common factor. Second thing I want to look for, is it the difference between two squares? Well, I have three terms, so no. Third question I should ask myself, is that coefficient of the squared term 1? Yes, it is. So that is the process I want to use, is when my coefficient of my squared term is 1. In doing so, we recall I just put out my binomial parentheses and take the square root of that first term and put it in the lead position. Then I need to find factors of that constant, factors of 10 that have a sum of 7. And if you can see them, great. If not, make a little chart and just go through that process that we used back a couple note-taking guides. So my two factors of 10 that add up to 7. In this case, I'm going to do a plus 5 and a plus 2. Since I'm looking for what's going to cause a 0 in the denominator, I take both those binomials and I say that can't be 0, x plus 5 can't be 0, and x plus 2 can't be 0. And now I'm going to solve each of them separately for x. So I'm going to subtract 5 from both sides on my first one. X can't be negative 5. And subtract 2 on the second one. X can't be negative 2. Writing this in set notation, x such that x does not equal negative 5, x does not equal negative 2. Easy as that. I'd like you to pause the video and give example 4 a try and see how you do. Remembering we cannot have a negative under the square root and you cannot have a 0 in the denominator. I'll see you in a few minutes when you're ready to check your answer. Okay, let's see how you did. We need to determine the domain of f of x equals the square root of x minus 3 over x minus 5. I can't have a negative under that square root, so my x minus 3 has to be greater than or equal to 0. I also can't have 0 in my denominator, so x plus 5 can't equal 0. Solving both of these independently, I'm going to add 3 to both sides, so x has to be greater than or equal to 3. Add 5, x can't be a positive 5. So your set notation should be x such that x is greater than or equal to a positive 3, and x can't be 5. That is our domain and our restrictions on that domain for f of x equals the square root of x minus 3 all divided by x minus 5. That's it for this video. Since I'm running out of time, we will do range in the next segment. We'll see you in a couple minutes.